Hello, my friend. My name is Jeferson Costa. I'm chemical process engineer, and today I'm here to tell you the 8 engineering deliverables that every chemical process engineer must be familiar with. And before starting this topic, I would like to share with you how it was born. And some days ago, I shared in my LinkedIn a post about this topic, asking people to answer me how many and which documents a chemical process engineer must do to design this system. And this system was a markup P&ID that I shared there in LinkedIn. And this post has a lot of views, and at this time it was more than 20,000 visualization, and I had many comments here and with my connections and other people that was interested in this topic. I will talk about 8 engineering deliverables. There are much more than that. For instance, my friend Peter Gabriel listed at least 13 documents that he believes that is needed to design the system shown in the P&ID. And there are other also great comments, so I encourage you to take a look in this post and verify each comment, and you will learn much more with my friends in LinkedIn. I will let the link for this post in this video description, so don't worry about that. And to start with this post, I would like to talk with you about the markup P&ID that was the beginning of all this story. You can see here a markup P&ID. P&ID, if you didn't know this anagram, is pipe in instrumentation diagram, and there are some information here that is erased because it is based on a real case and that I'm working with. So you can see that the stamp is not visible, and the supplier and some flags is not visible also. But the important thing to you understand here is that I have a gas plant where I take gas from a source, pass that through a blower that builds the pressure of this gas a little bit, and this gas is sent to a compressor for further processing. And as we have available gas, I mean we have excess of gas in this plant, we now have a new supplier that we can send part of this gas for a new supplier. And this P&ID shows a preliminary vision about how the system looks like to deliver the gas stream to the customer. And every time that you start a new project, you need to know information about the scope of the project, the schedule of the project, and the cost. And knowing this, my first approach is to estimate the main hours that I need to do the work. And you will be able to do that once you get familiar with engineering documentation and you get more experienced in plan design. You will start to identify which kind of document needs to be done, which kind of document of other disciplines should be commented, and think like that. So now I will share with you the timesheet control or timesheet estimate that we need to do in order to estimate and start building the process engineering cost for a plan design. So my friends, here we have the first engineering deliverables that every chemical process engineer must be familiar with. It is the timesheet control or estimate, where I use it to calculate the chemical engineering hours to do a plant design. This one that I'm showing you, it's a sample. It's not related with the scope of design that I have shown you, but you can learn a lot of things here. So I have some lines where I describe the type of document that I will develop, and in the right column I have the total hours for that activity. For instance, I considering in this case that I will develop a process engineering memorandum for cooling water. Just to let you know, in the timesheet control, it is related to material balance, so it is estimated that I need to do engineering memorandum and expend 12 hours to do that, so my total hours for this document is 12 hours. And I do the same for process flow diagram, for process utility diagram, and P&IDs that I evaluated in this scope of supply. That is not the same that I had previously shown to you. I have also other activities, and in some cases we have the equipment list, and you can see that for each deliverable I have a column for the quantities of deliverables that I need to develop, and for each unit I have the time that I spent for that deliverable in the total in the last column. So for instance, in this project it was estimated 171 automatic valve for this scope. I would expend 342 hours to complete this task. And more than that, I have also meetings to do, supports to other discipline, and consistency analysis to do. So total chemical process engineering hours to be expended in this project would be 1,250 hours. And knowing how much cost the chemical process engineering hours, we can calculate the total cost of chemical process engineering. And this is very important for the project manager because he needs to control the scope of the project, the schedule of the project, and also the cost of the project. The second engineering deliverable that I will share with you is the document list. Based on this, you will be able to fill your timesheet control. You will see during project development that sometimes you don't have a fixed step-by-step development of documentation, and sometimes you start to fill one documentation, and with the information with another we need to revise and update the information. And the document list is a great place to be familiar with engineering deliverables and start understanding how to estimate timesheet control. And in my point of view, it's very important that any or every engineering deliverable has a cover. So you see in this that we have the document number, we have some information about the project like the client, the job, and the area. We have the title of the document, and we have a revision index where you can describe in few words what was the changes that was done. And in the bottom of the document there is a table very important that is related to revision, and every engineering deliverable must have a revision control, because you need to be aware what is the document that you are working with, but most important, what is the revision that you are working with also, because when you are in a project, revisions may change very fast, and without that control you may lead to misunderstanding. This is a cover template for most documents that I develop in Word, Microsoft Word. And now let's see the document list itself. So it has information about the document number, the project itself, and revision, number of sheets, etc. In this case, it is divided by disciplines, but if I starting a new project, I will fill only the process engineering documentation for the project manager. Each document is not a document controlled by the chemical engineer, but you are part of the process of verifying and listing the documents that need to be developed during the plan design. So just to have an example for you, I filled the engineering memorandum and we have the document number here in the left. It's very important to add a revision for that, the data that it was issued, and in the comments I did a small explanation about what is inside in the engineering memorandum. So if you are starting a new project or if you are revising an existing project, it's my recommendation for you to take a look at the document list and verify the documentation that is available for that project and what is the latest revision for you start to do your work. The third engineering deliverable that I show you is the famous process flow diagram. It is one that most chemical process engineer knows or have heard about. And in summary, the process flow diagram, it's a graphic representation of the heat and material balance, and it is a document very important for chemical process engineer because we understand where things begins and where it ends and how the streams changes during the process and what kind of equipment is added to processing and etc. But sometimes it is used to make it easier to management understand the scope of supply of a new project. In this case, I have here the black lines that represent the existing facility and the red lines that is the new project that I'm working on. And although usually there is no control signals in the PFD, in this case I added that because it is very important to our customer understand how the pressure control will be done for him. So in this case we have a more detailed information about process control. And just to verify with more details, I have here the raw gas and its condition of pressure and temperature. I have also the raw gas composition, and it is a saturated gas with water, so I have a water separator in my plant, and I have two blowers here where it takes the gas inlet, builds some pressure and sends that to the compressor as we had seen in the markup P&ID earlier. And as we have a gas available, we'll send part of this gas to a new customer, and we are adding a control valve or an automatic valve in the pipe for the customer for control reasons and safety reasons. Once again, it's very important to you verify the stamp or the cover of each documentation, engineering documentation. In here you can see the revision, the data of issue, and in this document you can see if it is preliminary. There is also he did the document, who did the verification and approval, the number of the project, the number of the document, it's very important, local and country, and the name of the design company or something like that. It is based in a real case, but it's a sample, and all the information here is preliminary, and I will fill everything here based on the heat and material balance. And in this case I use the symmetry that is from Schlumberger. I will show you how it looks like. So here I have my screen with the symmetry, and to define the pipe size for delivering the gas stream to the customer, I use this, and that is defined based on the pressure drop between the time point and the battery limit. So to develop my process flow diagram, I need to do the heat and material balance. However, to do the heat and material balance, I need other information that comes from other disciplines like project management and plant layout. And so to do the pressure drop calculation, I need to know how the layout is, but as that is not a chemical process engineering document, I will not show that for you. And the fourth document that I show you is engineering memorandum. The engineering memorandum is a summarization of almost everything that we have seen up to now. I will add in the engineering memorandum information about the scope of supply of this project. I will add also local environment condition and what is the requirement for the customer at the battery limit and so on. And as I have told you, we need a cover to identify the document with a number, and we have also the revision index and the table of revision and execution of this document. One thing that I would point out to you is that for every engineering deliverable that you are working with, it's very important to have at least 2 people involved. One person would do the execution and verification of this document, and the other one will do the verification and approval of the document. This 2-step of approval or development is very important to avoid misunderstanding in the project development. It is most common in the plan design that you have another person to verify and approve your documentation, especially if you are just starting as a chemical process engineer. And just to give you a sample of engineering memorandum looks like, I will show the summary. So you can have in your project the introduction, system of units considered for that project, general information like weather and customer requirements. You can list also the system equipment for your plan design, and you could or you may add also the equipment list inside your engineering memorandum and calculations related to utilities like power consumption and water consumption also, and point out to some annexes in your engineering memorandum. In my point of view, an important document because it is a compilation of your scope of design, and different than process flow diagram, it is written, so it is made to be easier to any people read and understand what is going on in the project. And the process flow diagram is more for a graphic representation of the project, but is more related to the heat and material balance. And the engineering memorandum, you can have also information about the heat and material balance, but it's more general view of the project scope of supply. And the fifth engineering deliverable that we'll talk about is the line list. It is shared with the piping designer because we have information related to the process itself, but also about a piping system. So what is most important for us, chemical process engineer, to know about the line list is that we identify and add line identification for each stream that we will draw in the P&ID. I'll talk about the P&ID further, but the line list prevents the chemical process engineer from duplicating information for different things. For instance, I have a sheet B01 with line 001 and sheet F5 with the same line identification. So when you are developing your piping instrumentation diagram, most often you do that using the line list side by side, and that will prevent you from duplicating information and making your job harder. There are softwares, intelligent P&ID softwares that do that automatically, but if you are in a small company, most often you will fill the line list manually. And besides the line identification, you will also add to the line list the fluid description, if it is liquid, if it is vapor, or if it is two phases. You will identify from where to where that line goes, and add the P&ID sheet that this line is shown, and also information about the fluid conditions, like operation. That operation is the range that you do your heat material balance in order that your process is running well. For instance, if the average temperature in this process is 15 Celsius degree, acceptable variation would be, for instance, 14 to 16. So if your process is under 14 to 16, everything is okay, it's performing well. But for design reason, you need to know, or you need to inform the pipe designer what would be the highest temperature expected in that stream. For instance, if you have an uncontrolled situation, temperature of this line would reach 80 Celsius degree. The same is done for operating pressure. You have the average pressure of your system, but also you need to inform for pipe designer what would be the maximum expected pressure in your system, and that cannot exceed the maximum allowable working pressure of your system. With the design temperature and pressure, you can confirm if the material selected to this line is correct. Usually, companies has a handbook with piping specification that is identified in the line identification. So here, for instance, this line identification, line numbering, is the nominal diameter, fluid symbol, area, number, and material spec. This material spec, if you see the material spec handbook, is related to a set of material that already has the maximum allowable associated with, and the design temperature also for this material, and based on that there is also the schedule, and everything is set in the material, and it can be identified in the P&ID. It is very important to you be familiar with the line list and know how to use that in order to do your work as a chemical process engineer. The fifth engineering deliverable that I will show you is the instrument summary, or it may be identified also as instrumentation list. And while the line list is for piping design, the instrumentation list is for instrumentation design. So you need to inform some info to the instrumentation engineer in order that and it is very important also to you be familiar with the instrumentation summary, because you will use that side by side with your P&ID development in order to not duplicate information for different systems. So here you can see that I have, for instance, pressure indicator, the tag of this instrument, and the local where its information will be sent with. We have also an automatic valve that is just on off. It's not for control, it's only for blocking. And I have also here a pressure relief device, in this case a pressure safety valve with its tag and local and etc. There is a column for description of the service. For instance, pressure safety valve will protect B01 from overpressure. It is why we have a column here identifying the equipment or the line where the instrument is installed. you will inform for the instrumentation team or for the instrumentation guy the minimum, the maximum range of that instrument, and sometimes the set point and the engineering unit, in order that the instrumentation team can do the specification of an instrument. You can see that we have also here a place to inform the document number, who did that, who approval, when it was issued, and revision. And it is very important to you know how to handle the instrument summary or the instrumentation list, because sometimes we need to search for an instrument, and the P&ID there is a lot of sheets, and it is not an easy task for a specific instrument or instrumentation in the P&ID. So you have the instrumentation list to help you in identifying that information, and once you find that in the instrumentation list, you can go to the P&ID sheet and see instrument in the P&ID. The seventh engineering deliverable that I will show you is finally the P&ID. You will do your P&ID for the first time based on all the previous information or the previous documentation that you were working on. For instance, you had set the engineering hours to do a P&ID, you had added that in the documentation list, and you did the process flow diagram and identified the piping, instrumentation, and control that you need to add to do your scope of supply, and you had used the line list to identify the lines that you use, and the instrumentation list to identify the instrumentation number available. And most companies, or in many companies, there is also a manual valve list to make it easier for the operator to identify a manual valve in the field. I didn't show you a manual valve list, but it's very similar to a line list and instrumentation list. The main purpose is to make it easier to identify a valve and see if there is a number available for that, to identify that valve, and to see in which P&ID sheet you can find that. And here I have the P&ID. This one was made based on the preliminary markup P&ID. Many projects you will do a markup P&ID, and the CAD designer or sometimes the own processing engineer will use a software to do the P&ID drawing. And in this case we have a flag referring the sheet where it comes from, this line. So in the line list you know also from where each line comes from, and we have here the identification of this line. It has only the nominal size, the fluid symbol, and the area identification. And after that we have here a butterfly valve, 60-inch butterfly valve, and again the line identification. You see that it has changed its number, and you have the representation of flow metering. So we have here a flow indication transmitter, and it's very common in flow measurement that we need a straight line to not impact the flow metering, and with this it is more reliable measurement. And we have the pressure control valve here and a bypass for maintenance. So in case that the control valve needs to be sent or needs maintenance, we can block upstream and downstream of the valve and open the bypass to let the fluid flow to the customer. And here we have an isolation valve for battery limit. So there is a control philosophy for interlocking this valve, and there is also here a pressure indicator transmitter that will send the signal for the controller of the pressure control valve, and there is also a temperature device that will allow us to read the temperature of the stream, and in the battery limit we have a blocking bleed where it will isolate the customer battery limit from our process. You can see here that if you are familiar with ESA standard, the drawing is not according to that standard. However, that should not be an issue for you, because once you get familiar with P&ID, you will be able to read any kind of P&ID. Some of P&IDs, the most oldest one, are not based on ESA. There are also other standards that talks about piping and instrumentation diagram development, like ISO or PIP. So the most important thing to the chemical process engineer understand is that what's going on in the drawing. And as any other drawing or any other engineering drawing or deliverables, we need to have a stamp where we have the number of the document and the revision of the document. In this case, we have also the identification of the sheet and the number of sheets. It is only one because we representing the interface with the customer, and who did that and who verified and who approved that also. And now I will show you the 8th engineering deliverable for this project, and of course there are many other ones in a project design, but I separate this because it's not very common you hear about that. About this one, it is the tie-in list. Tie-in is the intervention that we need to do between existing facility or existing process and a new one. So as I have an existing process and I need to add a new pipe to deliver gas to the customer, I need to do a tie-in in the existing pipe. So the objective of the tie-in list is to show that is to organize that and identify that in order that the pipe designer can develop its project easier. It is very similar for other lists. So we need a cover to have information about the document number, and also the title, and a table of revision, and also the revision table with data for issue, execution, verification, and approval. And most important to show to you is a sample of tie-in list where we have 500 and tie-in 001 that is shown in the P&ID 00.0000-PE-PID-001. The P&ID number may change from company to company. That's not important. The most important to you when you get a tie-in list is that it shows to you which is the existing pipe or equipment that will have the tie-in, and the new pipe that will be added for this tie-in. In this example, we have a new 6 inches pipe that will be connected to an existing 10 inches pipe. It is important to you have a tie-in list to correctly identify the tie-ins, to not duplicate that, and also you can have a better view of the quantities of tie-in, because tie-in points interferes with the plant operations. There is tie-ins that can be done while the plant is still running, but there are others that the plant needs to be shut down and purged to let the work to be done. So if you have a tie-in list, the management and the operation and maintenance team will be able to plan better what is needed to let the job be done. And it is important also about the interference that the project is doing in an existing plant. There are many other documents in a project development, and it depends on the phase of the project that you are working with. So, for instance, if you are doing the conceptual design, you have a set of documents. If you are doing the basic engineering, you have another set of documents. And if you are doing detailed design, another set, commissioning startup, another one. And if you are doing plant troubleshooting, you may have others to review, develop, or update. And you can see some examples of documentation in the comments of the post. That's why I really encourage you to take a look on that. And you can find more of my posts in my blog, for instance, pipe numbering and much more in this blog. Just type jeffersoncosta.com/blog. If you want to know more about chemical process engineering plant design, you can also get into my Telegram channel in process. And in process, I share with you my day in the life. So I work as a chemical process engineer consultant. So usually I share with my members my daily tasks. You will have also updates for my YouTube, my LinkedIn, and much more there. And exclusive content. For instance, I did a site survey special video series there to share with my members. And you just need to download or to install the Telegram in your computer or in your cell phone and learn more about chemical process engineering and process design. Finally, subscribe to my YouTube channel and let me know your comments and which document would like to know more information about. My name is Jeferson Costa, I'm a chemical process engineer, and I see you soon.